This is the coursework support video for 6G6Z3003 Dynamical Systems and Chaos. The coursework is handed out on the 7th of November and the students will have to hand it in by Friday the 15th of December. Handback and feedback will be on Tuesday the 9th of January. Students reminded plagiarism is a serious offence, so please do not sit with each other when you are writing out your solutions. So this is question number 1. It's concerned with the tent map. You will be given some graph paper. You have to derive the functions t, t squared and t cubed, which is t of t and t of t of t. You have to show the analysis, and then you have to use a pencil and rule and graph paper to plot those graphs. If you look in the notes, you should find the following useful. So the tent map is discussed on about page 17. And if you see at the bottom of page 22, this is where, bottom of page 21, this is what we use. So this is a similar example where we're looking at the temp map when mu is 2. So here is the temp map t of x. In the notes it's explained how to derive t of t of x. So this is t of t of x, and explanations given there. And here is t of t of x when mu is equal to 2. And this shows you how to find the fixed points of period 2. Similarly, to find t of t of x, then there's an example here, and here is t of t of x, and here's the corresponding figure. Notice though, for the coursework you have to plot this on graph paper. You also asked to determine the stability of the fixed points of period 2. For question number 2, we have a simple 2-neuron module with one self interaction here. So we have a 2-dimensional map. We have to determine the number, location and stability of fixed points of period 1. Again, there are similar examples to this. For example, we've got the Henon map, which is in the notes. So here is a Henon map, and again there's an example here. So here is a Henon map, which is again a 2-dimensional map, and if you look in the notes it shows you how to determine the fixed points and how to use the Jacobian to determine the stability of those fixed points. There are also bifurcation diagrams in the notes, and you'll see that part B, you're asked to use a relevant program from chapter 3 to plot bifurcation diagrams. Bifurcation diagrams are given, so we've got graphical iteration. So here we have, so you can see program 3E, for example, and program 3D. So here are examples of programs for plotting bifurcation diagrams. So you can edit one of these programs to get the bifurcation diagram for question number 2. Question number 3 is concerned with fractals, and fractals will be discussed shortly. So again, you'll be given a piece of graph paper and you have to construct the Levy fractal up to stage 7 on a piece of graph paper. But we're going to go through fractals in the coming weeks. So you can't do question number 3 yet, but you will be able to in a few weeks. And then question number 4, again, is concerned with a 2-dimensional map. So we've got similar programs. Graphical iteration. So we've got here we have a chaotic attractor for the Henon map. So if we've got this map here, xn plus 1 and yn plus 1, we're given initial conditions, and we then need to plot the first 10,000 iterates. So if you look at program 3F, you'll see this is also an iterative map. So you can, again, edit that program. And then parts B and C, they are a bit more difficult, so you have to use MATLAB to try and solve these problems, and I'm afraid there isn't a similar example in the notes. And that concludes the supplementary video for the coursework for 6G6Z3003. Good luck with the coursework.